What's a simple description of cloud computing?
So cloud computing is a way of automating the provision of computing resources. So in the past, if you wanted a computer for a particular task, if you were doing image processing or if you were running a database or hosting a web server, you would physically buy a computer, set it up in a data center or your office or somewhere, manually install software on it and configure it. Cloud computing at its simplest automates the first part of that. So basically, instead of physically buying a box and putting it somewhere, you're using a software package to have those instances created and provisioned for you in somebody else's data center automatically. You can get additional functionality that actually automates the installation and configuration on top of that. But the simplest case for cloud computing is basically click a button and you have running somewhere connected to the internet a new server instance that you can use.
What kind of security does a cloud computing sort of system have?
So there are a couple of layers to that. The cloud instances you spin up themselves basically can have any security configuration that you want. So again, at its simplest, it's just a computer running somewhere, sometimes a virtual computer. You can usually get a bunch of cloud instances running on one physical box, but they're basically just instances of a server running some version of Unix or Windows, occasionally macOS, I think that's a thing. So you have whatever security configuration need to be used. You can have usernames and passwords, you can have SSH keys, however you choose. For the individual boxes, but this is kind of a deep question, but there are layers. So at its simplest, you've just got the on-box security, which would be exactly the same as, again, taking a box off the shelf, plugging it in your office, turning it on, installing stuff on it. On top of that, you can usually, most providers allow you to locate those boxes if you choose within a virtual private network. So devices within that network can see each other, but access into that is very carefully controlled. Incidentally, it's considered very bad practice to rely on that, because if that's your only security and somebody gets into your VPN, they own everything. So you generally want to layer these. In addition, there's also the security of the cloud provider themselves. So obviously you want to secure your instances, secure your virtual private networks, but you also want to make very, very, very certain that nobody can get access to your cloud provider. So if I've got an account with Amazon and I'm creating servers and using them in the cloud, I don't want somebody to be able to come along and create or delete servers without authentication. So there are two very distinct security issues there.
What pros does cloud computing have?
It's very, very flexible is the main advantage. You can achieve a great deal with very, very little upfront investment. As an example, one place I worked at, we had a very, very large data set, many, many gigabytes of customer data, financial data and so forth, spanning back decades, and we wanted to analyze it. In the past, that would have meant either hiring a specialist firm to do that, or alternatively buying some quite serious servers ourselves. What we did, in fact, was went to Amazon EC2, their elastic computing solution. We said, okay, spin up half a dozen or so really, really powerful cloud instances, do all the number crunching, and then spin them down again at the end of the day. And so I think it was relatively expensive. I think we spent the best part of $1,000 on it. It was some fairly serious stuff. But again, that's like the best part of $1,000, and that was it. There's no further investment, no maintenance, because at the end of the day, we turn them off and walk away. So there's flexibility. You can do. You can build some very, very robust systems on cloud computing. Netflix is actually a great example. It's a canonical example, in fact. And that, in particular, takes advantage of a characteristic of cloud computing called elasticity. So you can configure it to say, okay, look, I've put this website up, it's running on, say, one server. monitor the traffic basically. As the traffic increases, bring more servers online. As it decreases, take them back offline again. So you're essentially spending just what you need, and you can. It's tricky. I mean, there are a lot of caveats in that, but you can keep the user experience quite consistent under very variable load without spending more than you need to.
What cons does cloud computing have?
Oddly enough, having just said that expense is one of the pros, it's also one of the cons. It's not. Cloud computing can be expensive if you use it the wrong way. Because it's typically very expensive to run large, powerful instances in the cloud. Tasks that are very, very heavily compute intensive can sometimes, you're better off actually just physically buying a box and sticking it on a shelf. Alternatively, and a lot of the time you can actually re-engineer your software to take advantage of a cluster of lower powered cloud instances, so that there are ways around it. Security is an obvious one. It is theoretically possible to maintain a higher standard of security if you control all the infrastructure. In practice, that's usually not too much of a con, because realistically, most places actually, if you compare their security policies to Amazon's, they're just hopelessly bad in comparison. There are very, very few companies that can actually match the quality of security offered by cloud providers. Latency can be an issue because the physical machines aren't located in your office. Network latency can be a problem. That's becoming less of an issue in Australia now. Both Microsoft and Amazon and local providers have centres here. In places like New Zealand, it's really a problem. Latency can be a serious issue. But again, that's a con, because it's a pro as well as a con, because you can actually target specific areas. So you can say, okay, look, I'm building a website. I want to bring up a server in, say, India, because I know I have a lot of customers there, one in America, and say maybe the entirety of Asia can feed off one in Sydney, as an example.
What stops someone from being able to collect information without being authorized?
Nothing. That's probably not a great answer. So essentially, in theory, there is absolutely nothing stopping a cloud provider from accessing any of the images that they're running. So if I contact a hypothetical cloud provider, get them to spin up a Linux instance, there'd be nothing stopping them from infiltrating that box in a bunch of different ways. More likely, if they were going to do something like that, they'd do a man-in-the-middle attack or compromise the infrastructure that they run on. I mean, realistically, it's the exact same answer that you have for running your own server. You shouldn't really assume that there's no unauthorized data access. And this has actually come up very recently with the well-publicized NSA snooping into cloud computing systems. Is essentially the secure way to do it is client-side cryptography. So you're only ever putting encrypted stuff up on the server. So even if the server is compromised, the data taken off, it's still encrypted. In practice, that's not always possible. Sometimes the overheads are too high. So yeah, basically, it's hard to mitigate, and the fact that you don't have physical access to the box can be an additional concern. But in practice, if your data security policies are good, if you're using appropriate encryption, it's no more or less likely to be a problem than if you're running the server yourself.
What do you mean by a box?
So historically, a box just referred to a physical computer, literally a box of components that you bought and installed in an office or a data center. Usually that's the sense in which it's still meant, though increasingly, especially with the growth and popularity of cloud computing, a box can also mean just any server, whether it's a virtual server running in a cloud or a physical box sitting on a desk.
So it seems that cloud computing is expensive and insecure. Is that fair to say?
Kind of. So, to give you a concrete example in terms of expense, there's a guy called Eric Raymond who's busy building a software tool called Repo Surgeon. And it, long story short form, it converts very, very large databases between two different formats. And he was looking into cloud computing as a way of working on individual significant problems. And it turned out for him that it would be far more economical to just go and buy a very, very fast box and put it on his desk, because he was using it continually. He would be using it in that fashion under heavy load directly, just himself, for many years. So the return on investment would be very, very high. Whereas, for example, if he was just doing a one-off, if he needed a really powerful system for maybe 8 hours or so, which is how long one of these conversions is taking, although the cloud computing solution would be much higher in terms of dollars per hour cost, if you're only using it for 8 hours, ridiculously several orders of magnitude cheaper. So the expense question really does come down to how you're using it. Likewise with the elastic provisioning. The canonical example of that is university enrollments. They'll typically build a university enrollment system that will sit practically idle, like you could run it on a laptop, for 11 months out of the year. And on that 12th month, it just goes bananas. So again, cloud computing is far more economical there, because you'd have to buy a massive server farm of physical boxes and then just leave them sitting doing nothing for most of the year. So again, cloud computing is a big win there, because you just ramp up. And yeah, it is more expensive per compute hour, but throughout the course of the year, you're paying for just what you need. In terms of security, it's not that it's insecure, but that it does tend to brutally expose problems in your security. So because cloud systems generally tend to operate over the internet, by default they come up connected to the public internet in most cases. If it's much harder to get away with poor security practices. As an example, people building servers for use in their own office might make the assumption that everyone on the local network is friendly, and so they'll protect the local network from attack, but their individual office server they won't bother. And I mean, that's a bad practice. That will get you burned in a number of ways, but doing that in cloud computing, where it comes up connected to the public internet by default, much, much worse. So it's not intrinsically less secure, but you have to be more careful, and your mistakes are more likely to be harshly penalized.
What would you say the state of the industry is at the moment?
I'd say it's pretty mature. There are some very, very big systems and very robust systems, for the most part, built on cloud computing infrastructure already. Add two examples that spring to mind are Netflix, which is pretty much entirely cloud-based, and Amazon themselves. Their cloud offering grew out of the infrastructure that they built to support Amazon.com. It's at the point now where it is very unusual for a company to actually go out and buy and operate their own physical servers. But almost by default now, most of the developers I work with, if they're building a website, they'll be looking to cloud solutions first, and it would only be in unusual circumstances like the database conversions that I was talking about earlier, where you would consider buying serious physical boxes to run things on. At the same time, a lot of the tooling is changing rapidly. One of the strengths of cloud computing is that it's very, very easy to automate. You can write programs to build entire network infrastructures and configure them, and those programs themselves, the tooling around it, are still changing and evolving, and there's a fair amount of competition. Healthy competition, it's great, but there's still quite a lot of evolution happening.
I just want to take this time to thank you for your time and insight into the matter.
Thank you for the opportunity.